Okay, so let's look at type of galaxies. So according to Hubble classification system, there are spiral galaxies like this one. Then the barred spiral. So there's a bar at the middle of the spiral galaxy. And then the elliptical one, and the other one is irregular shaped galaxies. And then we can subcategorize these galaxies. So if you think about the spiral galaxies, so they have nuclear bulge and a spiral arms. So as you see here, there's a center nuclear bulge and then the spiral arms around it. So spiral arms have clouds that are forming new stars. So on these arms, we can find new stars that are forming. Then the spiral galaxies are classified according to the size of their central bulge and the tightness of their arms. So the three subcategories are SA, SB, and SC. So SA does have big nuclear bulge, SB does have moderate nuclear bulge, and a small nuclear bulge on SC. Then the spiral arms in SA tightly wound. On SB subcategory, it's moderately wound, and the SC ones, those are loosely wound. So by looking at the pictures, we can compare these spiral galaxies and subcategorize into three subcategories. So when we are taking pictures of spiral galaxies, one type is face-on pictures. So basically you kind of going on top of the galaxy and taking pictures. So here's a spiral galaxy face-on picture for SA, and this is for SB type and SC type. So as you see here, this one has loose arms and a small bulge. But this one does have tight arms and a big bulge. So it's hard to even see the arms of this, right? And this is kind of in middle, so that's SB. Then the barred spiral galaxy. So our Milky Way galaxy where we live is a barred spiral galaxy. So like normal spirals, but have a central bar. So bars are extended and making a linear bulge. So half as common as normal spirals. So then again, there are three subcategories: SBA, SBB, and SBC. So as I mentioned, the Milky Way is a barred spiral galaxy, and it's about 100,000 light years across. So basically, if you measure the distance from one corner to the other one, like like measuring diameter. So diameter is about, I'm sorry about that. So if you measure the diameter of galaxy, it's about 100,000 light years across. So if you could look down on it from the top, you would see a central bulge that's surrounded by four large spiral arms. So the Earth, is somewhere in one of the arms. So if we have a dark sky, we should be able to see the Milky Way. So if you're lucky enough, we can travel to a dark region, rural region, and we should be able to observe this, the galaxy piece. So spiral galaxies make up about 2/3 of the galaxies in the universe. So this picture of the nearby galaxy, which is NGC 6744, a Milky Way look-alike, was taken by the wide field image on the MPG ESO 2.2 meter telescope at La Silla. So that's a cool picture of another galaxy. We feel like they look alike, but they are different. All right, so the elliptical galaxies have no spiral arms and no disk. They come in many sizes, from giant ellipticals of trillions of stars down to dwarf ellipticals of less than 1 million stars. Elliptical also contain very little, if any, cool gas and dust, and show no evidence of ongoing star formation. Elliptical in shape and mostly old stars. So have you noticed, like, it's more yellowish color in the middle, right? Then there are 7 subtypes: E0, E1 to E7. So E0 being almost perfectly round and E7 being very elongated. So here's a picture of E0 and here's a E6 one. As you see, it's elongated, right? This is mostly a round shapes a galaxy. So there are giant elliptical galaxies, so 2 times as big as the Milky Way galaxy. Then the irregular galaxies. So these are really cool pictures of irregular shaped galaxies. So the pressure differences create these nice colors. So irregular galaxies have a wide variety of shapes. Both these galaxies appear to be undergoing interaction with other galaxies. Irregular galaxies. So here's a 2 picture of irregular shaped galaxies. So one is SMC and the other one is LMC. LMC is Large Magellanic Clouds. So universe is enormous, right? So you are just a microscopic. So keep your human relationships stronger. And thank you so much for taking Physics 103 class. And we had a hard time going into online format, but most of you got adapted to that. And I appreciate it. And I wish all the luck for your future education. Thank you.